Good morning, student community. Today we are going to see certain topics in course outcome 4. Okay. So actually we have already discussed the open channel flow, the characteristics, and we have already discussed what is notches, what is weirs, what is the difference between them. We shall see now small problems solved in notches and weirs. Okay. We shall start. Already we have done. So I am directly going on to the problem. So find the discharge over the suppressed rectangular weir, which is a 4 meter long, with a head over the crest as 0.3 meter. So by already we have learned this Francis formula and all. Okay. So this is a suppressed rectangular weir, right? You can see that how is the length will be equal to the width of your channel. So Q is equal to your 1.84 LH power 3 by 2. So how much is L is 4 meter and H is 0.35 meter, and we are substituting it and we are getting the value. You know very well the unit of Q is meter cube per second. Now I am reading it. This is actually a complex problem and compared with the previous one. So I am reading it slowly. The maximum flow through a rectangular flume is 1.8 meter wide and 1.2 meter deep is 1.65 meter cubes per second. It is proposed to install a suppressed sharp crested rectangular weir across the flume to measure the flow. So find the maximum height at which the weir crest can be placed so that the water may not overflow the sides of flumes. So assume the coefficient of discharge CD is equal to 0.6. So now we are going to place, we are having a rectangular flume. Okay. So the dimensions of that is given, and the maximum flow, that is discharge, is also given. So what type of weir is to be placed is actually a sharp crested rectangular weir. Okay, so what we have to find? We have to find the maximum height so that the water is not overflowing along the sides of the flume. Now, you know the formula for here. This is Q is equal to 2 by 3 into CD root of 2G LH power 3 by 2. Q is already given. L we know very well. Okay, now what? So what we have to find? We have to find the value of H. Okay, so we are getting the value of H is equal to 0.644 meter. So now what it is actually is, this is actually Z is the height of the weir crest above the bottom of flow. Then what it has to be? So this you can see here, the depth is actually 1.2 meter. So this Z plus 0.644 should be equal to this 1.2. So that should be, so no overflow. Okay, so Z. Now what happened to is the velocity of approach will have to be taken into account. We have to if you want to calculate this velocity, whether it has to be calculated. Now you know the formula. Okay, so now what you are doing is actually we are substituting all the values and you are finding out the value of V actually first, because we know what is the value of Q, so that we know very well. And I am substituting 1.65, 1.8 into 1.2 is actually my area. So Q is equal to VA, VA is equal to Q by A. I am getting the value of V. So from this I am substituting and finding the value of H. Okay. Now what happens here? I am getting the value for HE. I am getting this V square by 2G. I am getting this. Okay. So now what it is actually? It will be actually a velocity at entrance. That last also I am subtracting, isn't it? So only I am finding HE is equal to V square by 2G. Now velocity of approach VA square by 2G. Now what I am doing, I am taking this formula Q is equal to, you can see this isn't it, 2 by 3. I am substituting this and getting the value of H. Okay. Now after this first one, we have not considered the velocity of approach, but when you are taking it as in the reality conditions, you will have to find out the value of Z also. Next one, a rectangular notch of crest width 0.4 meter is used to measure the flow of water in a rectangular channel. Its width is actually 0.6 meter and it is actually 0.495 meter depth. If the water level in the channel is 0.225 meter above the weir crest, okay, above, find the discharge in the channel. So we are assuming CD is equal to 0.6. We have to take the velocity of approach also in that account. This formula is already we have, if your velocity of approach is being neglected, you get this formula. CD we know, L we know. Okay, H is actually, they have given in the problem how much it is, HR. Then the water level is above. So H is equal to 0.225 meter and again N is equal to 2. Now what I am doing actually here, I am finding out the value of Q. Okay, for now we have to find out the velocity of approach also. So as we did in the following previous one, I am taking this Q, I am just finding out Okay, now I'm just substituting and I'm finding out the value. What are the dimensions? 0.6 and 0.45. I'm finding the velocity of approach Q. So V by area. I'm doing this. This is a rectangular notch. Okay, so only we are getting side into breadth into height will get it as for your area. Okay. Now HE we know very well. So the head loss also we have to find out, right? So V square by 2G. Now HF is this H1 will be H plus this what it is actually 0.2285. Now I am substituting this, considering this velocity of approach. I am finding out this Q. Okay, actually this what it is I am doing is, after that I am finding out the velocity of approach. Okay, now this capital H1 will be equal to H plus HE. This now what I am getting, I am again substituting in this Q. This new value of discharge will be quite close. You can see that Q there is 0.07186, while here 0.0719. It will be quite close to the previous, and it can be considered as the corrected value of your discharge. Okay. Okay. Now I have done a problem in V0. So find the depth and top width of V0 scabber of discharging a maximum of 0.7 meter cube per second. The head should be of 75 mm for the discharge, and what it is actually discharge is 5.6 liters per second. So you'll have to convert this. Okay, if C is the same as that of a similar one, find it. Q is equal to 1.407 raised to 5 by 2. So we know very well for the triangular notch. Okay, this will be, you have to find the formula. So Q is your formula. Okay, and again you know very well Q is equal to 5 by 6 into how much is this? 10 power minus 3. That is from liters they have converting in terms of meter cube per second, right? And H how much actually? 75 mm. So 75 mm I have to convert in terms of meter into 10 power minus 3 meter. Now on substitution in your formula. Okay, so what we get it is actually, so I'm getting as 8 by 1.407 raised to 0.075. Okay, this you can see here. I'm substituting here, and I'm getting the value of tan theta by 2. Okay, now if H is your required one, then how you can put it as this 0.7 is equal to here. See, this is 0.7 is equal to here. So I'm substituting in Q is equal to 1.407 tan theta by 2 H power, and I'm getting the value of tan theta power by 2. Now I have to substitute it in a value. Q is equal to 8 by 15 3 root of 2G tan theta by 2 into H power 5 by 2. Okay, I'm substituting and getting the value of capital H. So top width is actually 2H into tan cube theta. As we know all the values, I'm just substituting and getting the answer. Thank you for your patient listening. We shall meet in the next video. Okay, bye now.